Hi everyone, welcome to Vishwablooms. So in this video, we'll be looking at chemical bonding, goal 10 resonance, class 8 of chemistry, Techno. So this goal completely deals about resonance. So first, what is resonance we'll discuss, and then I'll give an example, and we will then move on to MCQs of resonance. Now this example will be helpful for you for doing other problems in the MCQ part. So that is why I'm giving an example. First and foremost thing, what is resonance? So the phenomenon in which two or more structures can be written for a compound which involve identical position of atom is called resonance. So first I'll explain it in a simpler way. So the phenomenon in which two or more structures you can write for one compound. For one compound you can write two or more structures. When you are able to write, then for a compound, and it should have some identical position. I'll tell you what is identical position. Then this is called as resonance. Okay, now I'll give the example for this. So C6H6, generally how it is going to be: a single bond with carbon, single bond with carbon, and double bond with carbon, again single bond with carbon, double bond with carbon, and a single bond with carbon. And every carbon has a single bond with each hydrogen. Sorry, every hydrogen is going to have a single bond with carbon. Now this is actual structure for C6H6. Now what are all the edits? Like, the structure can be written in different ways, right? Two or more ways. Now I'll write the same structure in other way. Okay, now in that sentence it was like two or more structures can be written for a compound which involve identical position of the atom. Identical position of the atom means that this bonds needs to be changing with some nearby identical bonds. Like, now carbon bond, you can't go and put it to hydrogen bond because both are not identical, right? This carbon bond, if you want to change, you have to give it to some other carbon bond itself, right? So that is what. Now if I am going to change the carbon bonds, okay, I will change that also. I will write neatly. So that time what is going to happen? First, here one carbon, here single bond with carbon, here single bond with carbon. Previously it had a double bond, right? Now it is going to have single bond. Here also previously it had single bond. Now here it is going to be double bond. Okay, here it is going to be double bond with the carbon. Previously it was single bond. Now again single bond with carbon. Here previously it was double bond with carbon. Now it is single bond. Next, double bond with carbon. Here it was single, it became double bond. And here single bond with the carbon. Now all hydrogens equally we are going to give for each of the carbon, same bonds. So I have given hydrogen, each hydrogen. Yeah. So this is what is changing the structure. See, very identical, right? These two only we changed. Previously it was double bond was here and one more where it was here. That's it. Previously it was here. Now just the position changed. The identical atoms only it changed. Now this is only resonance. Now we'll move on to the MCQs part. So before moving on to the MCQ, this is one more important thing because you have some questions based on the bond order. So bond order is nothing but total number of bonds between two atoms in all resonating structures divided by total number of resonating structures. So this is clear, right? Now we are going to move to the assignment bits first. So these are the assignment bits actually. So first question we will see. The resonance energy of benzene is, so the resonance energy of benzene is 36 kilocalorie per mole. That is the unit of resonance. Next, second question. The stability of the molecule is measured by, see the stability, whatever the stability which is acquired by the molecule, it is mostly measured by the resonance energy. Okay, only by the resonance energy, because resonance is more stable than any kind of thing, right? So that is why. Bond order of CO3 minus 2. What is this bond order? It is option C, 1.33 bar. Okay. Identify the incorrect point regarding conditions of resonance. So if you read the textbook, easily you are going to get all the answers here, like all the points. So out of that, option A is incorrect. The relative positions of all atoms in each of the resonance form must be different. It need not be different actually, just it should have identical forms, right? It should change in identical atoms only. Completely it should not be different, right? That statement is not at all mentioned in the textbook. Now resonating forms only different position of electrons. Yeah, that is correct, because just now we have seen a double bond only changing means that number of electrons only is going to change. So that is the right statement only. In each resonating structure, number of unpaired and paired electrons are same. This is also correct statement only. Contributing structures should have almost equal energy. Yes, when they are contributing, that structures must, it should have almost equal energy. That is also right statement. The incorrect statement is option A. Clear? Now we'll move on to the next questions below, whatever questions are there. So the questions here are MCQ with more than one correct answer type of questions. Among the following, molecule exhibiting resonance are. Now when you check the examples only, it is there. Everything is there in the examples only. CO2 is going to exhibit resonance, O3 going to exhibit resonance, and CO3 2 minus also is going to exhibit the resonance, and benzene, it is, as you all know, it is obviously because the first question was related to the resonance energy of benzene, so obviously it should exhibit resonance. Clear? Now moving on to the statement type of questions. Here we have statements. So the options are already given to us. Option A says that all the statements are right. Option B says that all the statements are false. Option C says that option A, the statement A and statement B are correct, whereas C is incorrect. And option D says that A and B statements are incorrect, whereas C is correct. Okay, this is all about the options for the questions, statement type of questions. Sixth question, statement A. Resonance hybrid is more stable than any other resonance structure. Just now I have told, and it is right statement. Statement A correct. Statement B. The resonance energy of benzene is 36 kilocalorie per mole. First question only that we found out. So it's right statement only. Statement C. Energy difference between most stable resonating structure and resonance hybrid structure is called resonance energy. That is the definition of resonance energy. It is the same. It is also correct. So what is the option? Option A. Just write it. Okay. Seventh question. Statement A. The relative position of all atoms in each of the resonance form must be the same. Yeah, already I told, relative position must be the same. Now, statement B. The number of unpaired and paired electrons in each of the resonance form must be the same. See, same statements are repeated from the fourth question. That is true statement only. Seventh one, statement C. The contributing structure should be of almost equal energy. See, fourth question, D statement, same it is. It's also correct. So again, we are going to have option A here. Next, moving on to the eighth statement A. Difference in the energy between hybrid and the most stable resonance structure is called resonance energy. Just the same statement we have seen in here. Same statement. Obviously, it is correct. Very simple actually. The statements are up and down only. Statement B of 8.1. They have given that structures, two structures, are canonical structures or not, they are asking us. So they are obviously canonical structures because that is the CC bond order in benzene. So it is canonical structure. It is also correct. Statement 3. CO3 minus 2 ion exhibits resonance phenomenon. Third question also we had the same thing, and fifth one also same thing was there. So obviously this statement is also right, and all three statements are right. Option A. Now moving on to the next part. Assertions and reason type of questions are here in front of us. So let us solve them now. So first options, I'll clarify it. assertion and reason type of questions. Option A says that both the statement A and R are right and R is the right explanation of A. Option B says that A and B are correct and R is not the correct explanation of A. Option C says that A is correct and R is incorrect. Option D says that A is correct and R is correct. Sorry, A is incorrect and R is correct. So these options are for both 9th and 10th question. Okay, let us answer. 9th question, assertion A. The oxygen-oxygen bonds in the O3 molecule are intermediate between a single and double bond. Yes, obviously it is correct statement only. Now I will show that also. See, oxygen is here. It is having single bond with one more oxygen and it is having single bond with other oxygen and double bond with another oxygen. So that is why I could say that statement A, it is correct. So if you want, you can note this, even though it is already there here. Next, reason R. The bond order of O3 is 1.5. Yes, obviously it is also correct and it is the correct explanation also. So option A. Next, assertion A. The electronic structure of O3 is. Now just now I have shown, right, that is the correct electronic structure only. This is also reason R. This structure is not allowed because octet around O cannot be expanded. Yes, it is obviously correct because this octet around this O cannot be expanded. This is the wrong one, wrong structure. Okay, so our statement is correct because it is saying it is not allowed, right? So it is correct statement only. But is there any link between these two statements? No. So option B. Okay. So next, moving on, we have the matrix matching type of questions. Fine. Now, matrix matching column 1 and column 2 you have to match. First one, CC bond order in benzene. What is it? It is 1.5. It is B. Okay. Resonance energy of C6H6. What is it? It is 36 kilocalorie. See the resonance in C6H6 which I have drawn, right? That is 36 kilocalorie. What is resonance energy? Obviously option C. That is the definition only. So options are B, A and C. Yeah, option A. Okay. Next, sixth one, we have passage type of question. Please do read the passage so that answers will be clear. I am not going to read it. Okay. 12th question, choose a resonance hybrid of benzene. What is the correct resonance hybrid of benzene? So there are 3 given, right? 1, 2, 3. Now which one is the right one? Obviously it is 1 and 2. 3 is not correct. Only these 2 are there. Because just now also we have discussed, right? Next, 13th one, P. The actual structure of the molecule is said to be a resonance hybrid. It is wrong. Both are not linked, so it's wrong. Q statement. Alternative structures are referred to as resonance structures or canonical forms. Right, correct only. This is right. So P is wrong and Q is right, so option B. Next we have to see the experimental heat of combustion of benzene. Heat of combustion of benzene means when you are burning it, combustion, right? So that one. So option A, option B, and here the last one, what is the experimental heat, right? When you are combusting the benzene, it is 49.8 kilocalorie per mole. Actually this is the heat is going to be produced experimentally. So option C. C option. Okay, now with this we have successfully completed chemical bonding, resonance, goal 10 and chemical bonding chapter is completed. In the next video we will be looking at principles of metallurgy and there we will see. So thanks for watching our video. Do like, share and subscribe to Vishwablooms. Bye bye. See you in principles of metallurgy.